So here we are with Srini. I'm very happy that we finally got a chance to do this. And I'm here in North America. Obviously, you are not. So I think the interaction with Siderise, and it's not that's not where my background comes from, but I see your global presence and involvement in fire protection in general, in facades. So I think, you made the comment that your background's not being a facade technical guy, but I think you're going to be able to add an incredible amount of technical information. It's all relative to our audience. And as always, I'm going to use this as an opportunity to learn. So before we kind of get into it, I'll give you a chance to share your primary market focus, and we can go from there.
So we are based out of a town called Mustang in Bridgend. That is where Siderise comes from, and I've just completed my 10 years with Siderise, and being from UK, our primary market focus was and is the UK market, where we were established since we have established and we have a presence for the last 50 years. And one of the key market for growth is definitely Europe. And from there, we came into the Middle East and India, and then the Asia Pacific. But we came east and never went west. If from the UK.
So would you consider yourself like an equivalent to a Hilti?
Yes. So the primary application of the product is same. The edge of slab is the primary product that we manufacture. So there are lots of other manufacturers who do provide the similar systems, but we come from a background where we are insulation converters. So our primary wool that we use works as both fire and smoke seal together. So you do not need a secondary layer of smoke seal that is applied on sites. So it's a dry fit system.
Wait, hold on. Let's break that down, because you threw a lot out there, and so it works as. Say that one more time. I want to break it down by component.
So we are insulation conversion people, whereby we own the recipe for the raw wool that is used, that is called as the stone rock mineral wool. Okay.
Okay.
That recipe, while manufactured, is owned by us, and then it goes through a unique manufacturing process. When I say process, we convert the insulation direction from horizontal to vertical, because it has to accommodate the movement on your projects, right? And then we pre-compress that in our factory, and then supply it as a finished product to a site. And once it goes to the site, the product is very simple. You just have to cut it, compress, take the additional compression, and install. So what I meant to say was, you don't need an additional smoke seal layer on the top.
Got it. So I'm used to the compressed mineral wool and then that liquid apply to that spray applied smoke seal. So before we get into that, let's take 10 steps backwards. So I think we need to start here by saying why fire protection, fire resistance is even prevalent in facades, period. Major events, catastrophes, you can call it, that have raised awareness, materials that might be fire resistant via either glass or aluminum, concerns that have come up, and then we'll kind of get into the technical. You can use insulation and spray to remedy some of this. So what, the events in London and so forth, was that as much of a trigger for your market as it was in the US for fire resistance becoming a major topic, or were you guys way ahead of it like you are with everything else compared to us?
Like both of the UK market or the US market, the international market, well before those incidents in London, have always had a compartmentation in the facade curtain wall applications as a primary requirement. So these have been there for ages. If I say early 90s or late 80s. So for the UK market, for us, it all started when the Canary Wharf started to build up. That's when it all came in as an application, as a region where Canary Wharf, you see lots of high-rise buildings started to come up. And then we also had projects like Gherkin, where you had a different unique shape of the building, like a circular shape, or which you needed a product that could go and service those kind of design, the architectural intent. And so we have been doing that for the last 25, 30 years in the international market. In Dubai, so I'm based in Dubai, as you introduced, and for us, every country you go, you have a fire and life safety code, correct? So you have in the US also, you have the International Building Code. In the UK, you have the approved document B. So in Dubai, we have the UAE Fire and Life Safety Code. So one of the correlations or relation between the US and UAE is these both markets accept a ASTM standard. Okay, but when you're talking about the UK and Europe, it's the EN standard. So, but for testing the product and the application, both the standards would have you would test your product to both the standards. So for us, ASTM is not the market of focus, was not the market of focus, but uh, eventually we have to come to the West. So we are exploring our opportunities in North America. That's why you would have seen, that's where we have crossed paths also. And it's been an exciting journey to to discuss. So countries like India, where the market is developing, right? It's not as matured as a high-rise market in New York, in Manhattan, or in Canary Wharf, or in Dubai on a Sheikh Zayed road, where for us, a 80-story building is like walking down on, we would see 5 or 6 buildings together. But India is booming also. So India is also adopting standards or adopting the ASTM standards and making the compartmentation in facades between the floor slab and the curtain wall as a primary requirement now.
So this is okay, that you just said an important point about compartmentalization. So I don't want to get into really ASTM versus EN. I really want to focus on kind of what level of enforcement, level of awareness, if the principles just apply, are uniform across the board. But something we see a lot in the States that we don't really see, or I don't really see a lot of in Europe, is your traditional unitized window wall, which is set within the slab. It's not outboard of the slab like a curtain wall. So obviously when you're outboard of the slab, you need to manage that smoke or fire from floor to floor. So maybe it would be good for you to describe that, what that really means, compartmentalization, and what the objective is with a fire rated system or fire saving system.
So primarily when we take any curtain wall arrangement, we use a non-fire rated, load bearing external curtain wall, correct? When you're going for a high rise building. So these can be stick systems or unitized systems that you would use. So primarily the design intent is to have a floor slab and have a gap and then align it with the external curtain wall. So you have a gap which is on the edge of the slab, where if there is a fire in a floor below, the passage of fire already exists, right? For smoke or fire to go through that gap. So it's very critical to fill that gap. So that is why we term it as perimeter fire barrier or a slab edge fire stop.
So did you see slab edge fire stops from day one that unitized curtain walls were created, call it in the 60s, 70s, 80s?
I won't say right from the day, but I would say during the construction and while the projects were coming up, they wanted to mitigate the risk of fire. Okay, so if you look at conventional systems, if you go back, the conventional systems were to fill it with wool and put a galvanized tray on top and bottom. Okay, it's a good practice. So you can stop that, fill it with galvanized tray, but then you started to get designs of building which were circular, okay, which were curved or inclined, or you also had requirements for movement. So you had to design the buildings for wind load or thermal movement or seismic. So then what happens is you cannot use a general galvanized tray. You need a product that could accommodate the movement. That can
What was the point of putting the galvanized tray on the bottom and the top? If you just put it on the top, on the floor below, wouldn't it stop that smoke from making its way above?
It would, but then it's just a way of mitigating risk. To say that is how it would have started, is my assumption, back in 1960s, if you go back to how when Manhattan started or anything. But coming back to Canary Wharf or anything in late 1980s, we have seen just the wool being installed, okay, and covered on the top. That's been a conventional system. But then later on, you started to get products which were called as smoke seals, which were a secondary layer of smoke seal which was applied on the top of the wool. But irrespective of all those, the direction of the fiber of the wool was critical because it had to accommodate the movement of the buildings, because you have a floor slab that would move, or you would have a positive negative load on the facade. So the product that you fill on the edge of the slab should accommodate the movement.
Interesting. So to really break that down, if you have a 4-inch gap, you might have a material that has to be compressed 33%. So you might put it 6 inches of mineral wool and compress it. But you're saying just as important is the direction of the fibers, not only to accommodate movement, but also to slow the spread of smoke.
So no, so the wool, when it is manufactured, the fibers are always horizontal. So you have to cut it, you have to rotate it, and so that the reason, if you are installing the wool in the same direction, because of the compression and the movement, the wool will break. So for example, if you have a piece of paper and if you try to compress, you'll see the paper is going up like this.
Mm.
So the wool will break for you. And the wool, so if you have installed the wool, if you cannot compress it, and if you are having a expansion movement, then the wool is not going to be there. It's going to fall down if the fiber is in horizontal direction. Do you follow that?
Yes. Okay, so how does this vary just a typical mineral wool versus like a foil-faced mineral wool?
So in our foil is so when you're taking a conventional thermal insulation, which is a wool of a stone rock mineral wool, for example, the aluminum foil is acting as a vapor barrier, correct? So in our application of Firestops, you really don't need the aluminum foil to have as a vapor barrier because you're not having a vapor control between two floors in that gap. But
Mm-hmm.
as Siderise, what we do is we use the aluminum foil to pre-compress the wool, hold the pre-compression of the wool, so that you have a foil on top and bottom which holds the pre-compression, and uh, and we don't use it as a vapor barrier, but it acts as a layer. So when it comes in contact with fire, the aluminum foil will delaminate and the material would relax.
So do you see a lot of spray foam applied or in facades, or it's predominantly mineral wool?
No, it's only mineral wool. The foam and the so earlier we used to see sealants applied on the joints of the galvanized tray, defined as smoke seals, but those days have gone. So there are standards to which your products should conform. You should have a conformity certificates from third-party certification bodies like UL or Intertech or the ICC-ES evaluation services in the US, which is part of the which is also the author for the IBC. So they all
Mm.
issue a certification for the products, which means they come to your factory, audit your product, and then they witness the test, take the test report, and then give you a certificate to see this is the application in which you can use the product.
How much custom unitized curtain wall do you see, and how much enforcement is then applied when you're steering away from an off-the-shelf system that might be already pre-tested?
Good question. So the curtain wall is basically when you're looking at a slab edge detail, right? The curtain wall is non-fire rated, and then the spandrel is obviously non-fire rated, and the spandrel is filled with insulation. So the only weak area when it is a non-fire rated curtain wall, you have the mullions are the weak area because the mullions would run continuous, and your insulation is but between the two mullions, correct? So the insulation is recessed. So that is why a non-fire rated curtain wall is taken for the fire test, and the mullions are always protected. They are not exposed to fire. That's why in projects you will see the mullion protections also being applied. So as a manufacturer of Firestops, we have tested with unitized curtain walls. We have tested with stick curtain walls. We have also tested with the European type curtain walls for unitized, which is the female-female connection instead of a male-female connection. So so we have explored our opportunities to our limit, to the knowledge that we can get support from partners, and uh, since it's a typical non-fire rated curtain wall, if you look at certifications and listings, they would refer the curtain wall as tubes of this section and this size and this. They would not come and say, oh, this is a curtain wall system from X manufacturer or my Y manufacturer. So, and the ASTM route is you take a curtain wall system, you install it, you have a window. So you have the same type of construction of your spandrel panel. Okay, you have a window where the fire would come from inside and outside, and then you have the spandrel and the perimeter barrier, and you assess the performance of that. So it's very real life condition is what you use in your test.
So what happens when you run into atypical conditions, whether it's some type of field applied post-installed anchor or even the P-clip anchor, which might interrupt your fire safing?
Yeah, very good. So as and when we started to improve our systems, right? So in the Middle East, what we have seen the typical floor slab thickness of 200, 250 mm, okay, or sorry, 8-inch or 10 inches. So the Firestops, if you see in the market, is typically at around what do you say, 8 inches or below, 6 inches or 8 inches. So our products are sitting in that same thickness of 120 mil, 4.5 inches. So when a project comes to us, we would look at where the bracket is there, whether it's a face mounted bracket or a top mounted bracket. If it's face mounted bracket, we would ideally like to relocate the fire stop to the soffit, flushed with the soffit, so that the bracket is not exposed. Okay, we protect the bracket because that is the one which is holding your curtain wall systems together. And if it is going to interrupt, then what we would do is we would have fire stops on both sides and then protect the bracket alone from the below from not being exposed to fire. But now what we have also, we have test data to provide to have a face mounted bracket installed in a fire test so that we can say how the face mounted bracket is treated. And then we can mitigate that and have a installation process on site, if that makes
So do you
sense.
see a lot of enforcement or policing on site where they're actually witnessing the install and monitoring progress just to verify?
Yeah. So all the facade consultants or fire engineers on the projects. So there is an ASTM standard to say how you inspect fire stops for perimeter slabbage. Okay. So when you're, and it's also the manufacturer's responsibility to make sure that these installations are correct. So I may have the best product. I might eliminate the human error by pre-compression in the factory or giving a vertical lamella in the factory, but that product can still be installed wrong. So as manufacturers, multiple manufacturers today in the market have started to give out inspection apps, audit apps. So you inspect, so as you install, you can do a QC process. And for example, in Siderise, you can download an app from App Store, and then you can put in your project information, and it's a series of questions, right? So do you see the compression? Do you see the brackets? Do you see the foils? And then once you take photos and finish the QC process, you would get a report. So this is a contractor's QC report, but then you put a work inspection report for your auditors or your fire engineers or your um, project consultants to come and do their inspection. But I would say followed on every project. It is
Is
done.
there for the owner to get his TCO, temporary certificate of occupancy, or be able to turn over the units, does somebody ultimately have to sign off on the system or bless it that it's installed per documents?
So I'm not aware of what that process is in the US, in the States currently. But for example, you have the California State Fire Marshals, okay? So they have a website where you can populate your test certificates to the standards they have listed and get a document to say your product is approved for this under California State Fire Marshals. Same in Dubai Civil Defense, for example. These people are called as authorities having jurisdictions. So they would give you a certificate saying that your product complies for this test and standards. But on a project to project basis, for example, if I take Dubai for an example, we have the House of Expertise who would who would be the ultimate authority who would inspect 20%, 40% periodic inspections and then close the building off and then get an authority having jurisdiction certificate of compliance for the full project, which would include all the fire stop systems, not only the facades or the perimeter barrier, but the through penetrations, the construction joints between concrete floor slabs. So you would have multiple approvals that are required, multiple applications which are there on projects, which you cannot, it would be hundreds of systems that are there that would need a compliance.
Yeah, I mean, I think when you start the project, you set this precedent of perfection and you do a Firesafing mock-up and everybody goes and blesses it, holds hands and says, this is wonderful. And then you're 60, 70, 80% of the way through the job and owner's running out of money. He doesn't have enough budget to have his inspector go out there. You know, his schedule's getting quicker and quicker. I spent many years doing inspections, and I would go and walk the perimeter of the 37th floor or something and literally see a construction worker put his boot right through the perimeter. You just see these holes and penetrations right through it. And so there's no way of actually verifying the system post construction, especially if it's all concealed. I mean, you could do whole building blower door testing to verify, you know, air tightness, but there's no real way of finding out if you have penetrations in your fire stop.
Absolutely. And that is what I say, that passive fire protection can be done correct only once, that is during the construction. Once it is done, you cannot go back because you cannot identify and you cannot correct it later. So it has to be done correct the first time. So even if it's going to be few thousands or few dollars higher, I would expect somebody to do this
Do
correctly.
it right.
Yeah.
Yeah, and the one area that I think is overlooked too is shear wall applications of curtain wall, because it's only once those panels are stacked on top, you can't see that horizontal joint, and all of a sudden you run into the issue of that chimney effect.
Correct. Which is bringing us to the next question, right? So, which is now I would say a burning question in the states with the New York building code, which is mandating something called as fire blocks. So so wherever you have this core wall and you're having a cladding element, you want to mitigate the risk, the chimney effect, as you rightly said. So you should fire block every floor. So then it comes down to the discussion of it. You gave an example of a curtain wall application, but there are many projects which would use cladding as an example. So rain screen cladding, and it could be stone, terracotta, aluminum composite panels, solid aluminiums. You can go high pressure laminates, cement boards. So you have to mitigate the risk of fire spreading through the chimney. So there are two important points which you said. So wherever there's a core wall, ideally the source of fire is inside the apartment, right? So you have to vertically compartment, which will be the first fire stop or the first protection layer. And then if the fire breaks that and goes into the core area where you have a chimney effect, then you have a fire block every floor. And
So
these
do you see it necessary not only to have that first vertical line of defense, but to have it every floor, or maybe periodically every 4 floors or 6 floors?
This is a very common question. Everybody, we have had projects where they say, "Oh, we will do it every 3 floors." But my question back is to say, who's going to sign off to say which floor you are going to start, and which is going to be the first, third floor? So who's going to sign that off? So that is the question. And when you do an NFPA 285 or a large scale system test, if you have a window, it's like a picture frame. So you do it on all 4 sides, because you would never picture frame only 3 sides. You have to do it 4 sides. So
Yeah.
it's like that. And then you have a horizontal fire stop at every floor. And now there is lots of industry trade bodies. For example, in New York, you have in the States, you have the RAINA, which is the Rain Screen Association in North America, which is educating the industry. And there are continuous development and learning programs which they have put forward in how the fire blocking has to be done, how to mitigate that risk in core wall areas. And because the aluminum composite panels also, or the solid aluminiums or the claddings also contribute, right? So it has to work as a system, which
Do
then
you
take,
think we're heading, go on, and then I'll ask. Go on.
sorry,
Sorry.
hold that thought, because once you go into that application, right, you also have whether you want to ventilate it or not have a non-ventilated system. So if you have ventilated system, then you have to give provisions for drainage of water, rainwater, or circulation of air to avoid condensation, for example. So then you go
Mhm.
into a rain screen application. So then you cannot use the same principle that we use for a curtain wall on the inside of the building, because that is pressure equalized. When you go outside for a rain screen system, it's not pressure. So you have to make sure that you have a ventilated system to circulate that pressure.
Do you see a lot of precast concrete in the UK or Dubai or India?
So we see GFRC and GRCs popular. We see precast concrete on projects which is having a flat walls uh, as a combination with a floor slab. But in this part of the world, we have seen an increase in GFRC applications on buildings, on high-rise
So,
buildings.
okay, and how does that perform, relative to a curtain wall? Is it, I don't really, I guess it depends on if they're using some type of spray applied mix, and if they're setting it to a backup steel wall, or what that actual construction looks like.
So it's a very common application, right? Same like a rain screen system is what it is. Only thing is the thickness of the glass reinforcement is different. It's a bit porous material. It has air trapped in it. So again, you have the large scale system tests like the NFPA 285, which I mentioned, or when you come to the UK, it is the BS 8414, which is the standard to which you test. So these all products have gone through those testings to say that the propagation of fire is not a risk on using these kind of systems. The only change or only thing that I have noticed is because the air trapped inside the panels itself, right, for the GFRC. So when it comes in contact with heat, you would see spalling on the concrete or the
Right.
panels. So that is one thing that we have to expect on those kind of panels.
Do you think the industry is trying to make various cladding components more fire resistant, or accepting that aluminum is aluminum, insulated glass is insulated glass, and so we have to work within that constraint, and everything around it has to be improved?
Um, I see the market going towards improving the reaction to fire, I will call it, okay? How a product reacts. So you have a classification to say whether the product is A. For example, if you take solid aluminum, it will be class A because it is non-combustible. But then now you have started to see products from A2 from aluminum composite panel manufacturers. So these have limited combustible, okay? So I see the markets moving towards the A2 or B1 classification, and also solid aluminiums have been very common now in lots of projects, though there is a challenge of how you fabricate it, but it's becoming very popular now. In the UK, it's solid aluminiums are go-to products now in the market.
Have
Apart
you
from
seen any vinyl products?
high
Uh,
pressure laminates, compressed high pressure laminates are very popular.
sure.
We have also seen brick slip systems becoming very popular. So people
I
are
think
going
it's
back to traditional bricks.
it looks nice, I'd say. I think it's important to share the message that the idea behind these systems is to not completely stop the spread of fire, it's to slow the spread of fire.
Correct. Absolutely right. And it gives your buying time, right? So the idea of passive fire protection itself, so it's the same like a fire triangle. You have three triangles. One is basically the suppression systems on the projects. One is the deduction systems where you have the smoke detectors which will warn the occupants to say you have to evacuate. The suppression system is to make sure that the building is cooled down, but you have passive fire protection or compartmentation, which is very critical of the three triangles, is not to spread the fire from one zone to another zone. So what you're basically doing is buying time for the fire not to spread and giving time for the people who are occupying to exit the building safely. So,
Yeah,
and
I
then
think
you look at this.
there was an animation kind of like yours, and seeing these animations are incredibly helpful, where you watched a time lapse and it was basically 90 minutes, 120 minutes of the smoke developing, the fire developing, and
Correct.
materials starting to melt, and then just again buying time for pedestrians to leave. So the idea being eventually after 120 minutes, that system might fail, the glass may explode, the mullions may melt and fall apart, but ultimately, like I said, the 60, 90, 120-minute rule is what's trying to be implemented.
Yeah, absolutely. And now high-rise buildings, the firefighters have also, the systems have improved. The people who fight fires, I mean, big salute to them, who don't even know what they are going to see when they reach the site, right? And they are expected to reach within 4 to 6 minutes of the first information, and they are all ready to come anytime. So the systems are improving. So there were also projects where there were case studies where they wanted to fix sprinklers on the external of the building, so which can make sure that you can, if there is a fire, it can be used, it can detect on its own, and then a sprinkler can work on its own. So companies like there was a test lab in Dubai called Thomas Bellwright who trialed a few versions of external sprinklers also on projects. So continuously these mitigation of risk are being evaluated, and they are also evaluating on how to improve the systems, because when you have a firefighter, right, your fire engine or externally you have a limitation to reach height, so they are going to go through inside a stairs, or they have to reach that. So
Mhm.
so these systems are improving, and that is why you see more stringent requirements in compartmentations that is coming up. Codes are emphasizing. So in Dubai, for example, the one of the GIF files that you saw, um, we have a requirement to have a spandrel height of 915. Okay, it's basically to avoid the leapfrog. Okay, so that is one of the points that is there, but there are countries and codes which say that if you have an automated sprinkler system in your building, then you can mitigate that height of the spandrel and reduce the spandrel height, because you have a sprinkler system which would activate and cool the building.
Wait a minute, let's hold on. So
Yeah.
that's an interesting topic. So you want to mitigate the leapfrog effect, excuse me, where you get fire spreading from one floor to another. So by code, you're dictated to have a minimum spandrel height.
Yes, which is a
And so you're
914
saying
mm.
if you incorporate a sprinkler system exterior or interior, you're able to eliminate that requirement?
So when we take the IBC for reference, okay, International Building Code, so there are three clauses where we can use an exemption, or there is a mention of an exemption. One is buildings less than 15 meters in height. second one if it's an open car park, and the third one would be height of, an automated sprinkler system designed for the project as per the NFPA references within the building codes. So if you have those, one of the threes, then you can reduce the height of the spandrel. Okay, which is kind of argumentative, but it has references and it has case studies on how it works. But in Dubai, you don't have those three exemptions. You have only two exemptions. So in Dubai, you would see lots of projects with that stipulated 915 mm of spandrels. But talking with Siderise, we have reduced spandrel test also. So we referred ASTM standards, right? Within those standards, we have tested for lower spandrels also. Okay, where we can say that the fire risk or the leapfrog, though the 2307s do not assess the leapfrog, but it's still, you can test for a lower spandrel.
It's hard for me to imagine. So a fire melts the glass and makes its way through, and then it's on the exterior, and its first, I don't know if it's driven by wind, but its first instinct is to go up and make its way into the next floor.
Correct. So if so, to that particular point itself, your sprinklers are activated and your cooling down process is started. So for example, then aluminium will start losing its integrity, is what I call, at around 350 degrees Celsius approximately, or start melting at 450 degrees Celsius. So the sprinklers activate at around ambient plus around 62 degrees Celsius. So sorry, I'm talking in Celsius.
No, it's okay. It's okay.
So that's the idea of how the sprinkler would activate, and it would start the suppression process. So these fire stops would restrict the passage of fire internally. And then, so that's why the leapfrog is not a big consideration if you have a smaller spandrel. But whatever is the spandrel which is exposed from inside should be protected. The mullions in that location should be, irrespective of the height of the spandrel, whatever is the defined height, you will need to protect that mullion.
Are there ways to do simulations to simulate the effect of fire, and maybe that would help in the design of custom systems?
I think it's a good opportunity to do a CFD modeling to see how it would work. I'm sure there are industry experts who could do that, and it could be welcoming to see how. But we can give data of the time temperature curve of how the test was done, and then use that as a benchmark to stimulate to see how the spandrel would work. Maybe
It's because I think a perfect example is acoustic testing. If you do acoustic testing on site or in the lab, and you run, 5 tests in each condition, you're probably going to get 5 different results. So it's very unpredictable. And in other means of engineering, whether you're doing structural analysis on deflection or moment of inertia or whatever, the results are more predictable. So how we can build in some higher level of comfort upfront during the design phase to be able to anticipate behaviors.
I think it comes with data, more test data that we have as reference. So for example, you said you are doing 5 different tests, right? So you can pick 10 you have data for 10. And probably if you have done it for 10 projects, you have 100 data. If you have a similarity of the systems, and then start building from there, because today AI is very good. So
Yeah,
probably you
I
can.
hope we'll get there.
Yeah.
Yeah.
And there are fantastic websites available. For example, in the States, there are manufacturers who would give a data system selector for a fire stopping system. So you go, you tell them you have a unitized curtain wall, you have a backpan which is of metal, you say you want only 3 inches of insulation, not 4 inches. So you can build your system and say, oh, this is the final design. For example, you may have a gap of 8 inches, okay? But then going on a higher of on an inclined facade, you may have 10 inches. Then you may require an engineering judgment for somebody to come and say, okay, using this data, the product will perform on this condition. And all this are coming into easy process for as a selector, if I'm a user, I can easily select these systems. So I'm sure that CFD modeling is not far away if we have test data.
It's funny, as you were saying that, I was thinking about how easily you can build a car from home and just go on the automotive website. So at what point we'll get to that point with facades where you can just hand pick your dimensions and materials and aesthetic and then perform some type of simulated test on it?
Yeah, I saw one of the podcasts that you did with Eugene. He is a great he has great visualization skills, so he can put anything what you think into a visualization. So
Sure.
I am sure it's not far away that we would get there with industry experts who have been there in the industry, who have so much experience. And data, for example, data is key, right? So as much as you feed into the AI, you get better responses. So data is where you start collecting it and then filtering it.
Why do you think people are so afraid of this topic around fire stop or fire saving strategies? Whenever I ask or bring it up, it just seems like a very sensitive topic.
Tough question. I think it's the responsibility matrix, right? So who? So what do you? So if I'm giving you you have a request and I'm giving you a solution, and the confidence for me is backed by the how much tests I have done, for example. Okay, so there are industry experts who have that experience who would be very confident, but with I think the facade market has grown so much internationally that the proportionate people who are uh, so you will see lots of acoustic people in facade, but you will not see so many people on a combination of fire and facade. You will get some very good fire experts in the industry, but facade is there. So people like Eugene understands, but there are other people also who are there in the industry who are educating themselves, who are learning themselves, and who are spending time to make sure that they are designing it well. So
Mhm.
I think it may be only a temporary thing before the industry starts to enhance their skills.
I hope so. So this was a great conversation, and very informative. I guess share where people can reach out to you, and it's also very interesting that you guys are considering coming stateside. We discussed that a little bit before hopping on here, so it'll be helpful to share that and what your plan is moving forward.
So again, ASTM is the route to compliance, right? So if though we have lots of test data to EN standards, or for example, Australia has an Australian standard. So we are already working in 23 different jurisdictions, out of which there are 6 different test standards. For example, China has a GB standard, Korea has a different standard, India has a different standard. So, but for us, ASTM is the route to compliance for key markets like Singapore or Saudi Arabia or even states. So uh, we have done tests for ASTM E2307s, which is the requirements, but we are not there yet with the number of tests that is required. So we have to do a whole lot of series. So we have to reduce the spandrels, backpans. There are various combinations that we would like to do. So with standard applications, we are already ready with the market to service the market. As I said, as I introduced, Siderise, we are solution providers in fire, thermal, and acoustics for facades. So something what we also do is if you have a facade system where you want to mitigate or reduce the sound transfer from outside to inside, okay? And when you look at a building elevation, 85% is glass, but 15% is your aluminum system, which is empty, which will reduce the performance of the glass when the sound is coming in. So we also provide solutions to enhance the facade systems to make sure that you get the better performance by removing the empty void inside the mullions. So we have started to see and interact, see requests and interact with people who are very keen to learn. Um, and I may be wrong in saying with the data here, but I see lots of facade systems manufactured outside US coming into the US. So we have seen systems from India, Vietnam, Thailand being built. Dubai, for example, we have fabricators here who ship products into the stateside.
Correct.
So
Correct.
one of the risk one of the mitigation points, what I would say is the insulation type, right? So a system in the US would have tested with X type of insulation with a smoke seal, but that would have not been available in this market. So even that is so things are while speaking to people, there are some dead ends that we are hitting, which we want to make sure that we are able to contribute to a better construction and build a safer tomorrow. So
Sure.
we are just starting small steps in the States, but probably next year you will see us more active. But this year you would see us more interacting, education. We want to engage with forums where we can share our experience.
Yeah, well, this is a good opportunity to start. So thank you for hopping on. This was wonderful. I really appreciate you coming on here.
No worries. It's a pleasure to always talking to you. As I said, we always there are lots of people in this part of the world who refer what you do. it's openly sharing the information, right?
Correct.
That is all it is about. You share as much as what you see. It's because it's real life. You walk around and you show them. It's more representative and related, and people can relate to what you're saying. So
Absolutely.
thank you for giving the opportunity or calling me in to have a chat.
Of course. All right, Srini, thanks again.
And so, no worries.